Hi everyone, this PowerPoint is on the environmental impacts of urbanization and some ways that we can mitigate urban runoff. This PowerPoint covers two topics. So the impacts of urbanization is topic 5.10. The enduring understanding, as with many of the ones in this unit, when humans use natural resources, they alter natural systems. And the learning objective describe the effects of urbanization on the environment. And that's what we're going to spend the bulk of this PowerPoint with. And then we're also going to talk about topic 5.13, methods to reduce urban runoff. And the enduring understanding is that humans can mitigate their impact on land and water resources through sustainable use. And the learning objective is describe methods for mitigating problems related to urban runoff. As usual, I'm going to skip the vocab, but you guys can return to this as needed. So let's start with the basics. What is urbanization? Urbanization is the process by which people shift from living in a rural agrarian setting to an urban area. These shifts include changes in labor that result from moving from a farm-based economy to an industrial, modern, tech, digital economy, and mark stages 3 and later of the demographic transition. Okay, obviously that's just some generalities. These cultures are still going to have lots of agriculture on the outskirts of these cities, but just purely moving to the cities is urbanization. Okay, and I have two pictures of some of the larger cities on the planet. Here's Cairo, one of the oldest cities on Earth, if you count the entire Cairo area, including Thebes and all of that. And then Tokyo, and if you include the greater Tokyo area, it's the world's largest city by population. Now, I'm going to spend a very brief amount of time on urban planning. We'll talk about this a little bit more in class when we compare and contrast North American and some European city planning. But most cities, especially in the old world, Europe, Asia, Africa, are very old, and they've been built up very organically over the centuries. And that's been a challenge for urban planners in the 21st and 20th centuries. Okay, so city planning has been very variable across time, space, and cultures because these cities, when they just started as small, maybe agrarian or fishing towns, mining towns, forestry towns, they grew up very organically, and they tended to follow the natural contours of the land, whether that is the topography, whether it's rivers, whether it's the ocean, whatever natural features they tend to follow. Okay, so it makes modern planning a little bit more difficult because you have to work around the old structures and the history that's already there. Okay, and a lot of cities are surrounded by natural obstacles or natural barriers that prevent a lot that create challenges for planning as well, which is why I have a picture of Hong Kong here. Not only does Hong Kong have the old district in the center of town, you notice where all the smaller buildings are. That's that history that I was talking about, and you notice that the way the streets are aligned, again, you're working with that history of how the city has grown over the years, over the centuries. But what I really have the picture here for is to talk about how it's bounded in by geographic barriers. You have parks, forests, and mountains to one side, and you have the ocean to the other. So you have to be very cognizant of how you plan. And much of this planning is, as you can see in Hong Kong, is building up and not out. So that's a phrase that we'll hear quite often in this, is building up and not out. They can build vertically, but they cannot build too much more horizontally out into more land. Okay, but we'll get to all that as we go. So remember, when we hear impacts, we're talking about both positive and negative. There are environmentally beneficial impacts of cities. One of those is a high population density. We have over 8 billion people on the planet right now, just hit that mark last month. And with this high population density, I'm recording this in December, so it was last month when I recorded it. It'll be a couple months when you guys hear it. But anyway, high population density. You can fit a lot more people into cities than you can into a rural area, simply because you have the ability to stack people into apartment buildings, and you can have very, very high population density. So you're able to reduce the amount of living footprint that a person has. It doesn't reduce their ecological footprint, but it reduces the amount of literal space that they need to live, right? You can have like a few dozen families living in an apartment building, or you can have those few dozen families spread out onto suburban single-family homes, and suburban single-family homes are going to take up a lot more space and alter a lot more habitat or alter a lot more environment. Okay, so that reduces the number of people that possibly live in rural or natural areas, further protecting natural areas. And again, like I said, you have the ability to build up and not out. Public transportation is so much better in the cities than it is in the suburbs or in rural areas in general. Obviously, challenges exist in both locales, but public transportation tends to be pretty good in cities, and especially cities that invest heavily in their public transportation. Denver isn't so great of an example of that, but New York City, when I rode the New York City subway cars for a couple months when I was living with a friend in New York City in college, it was so easy to get anywhere that you needed to get to in the city via the subway and the bus system. That's not quite the same as in Colorado, but Colorado's getting, or Denver at least, is getting a little bit better. Proximity to all the stuff that you need, proximity to local goods. We'll watch a video about this tied to city planning and class, but if you have self-contained little communities in the city where everything is within walking or biking distance from your home, then your fossil fuel use from transportation is so much less than it would be in a suburban area where you have to drive virtually everywhere. So those are just some of the big benefits of cities. Now let's talk about the environmental disadvantages. The first one I'm going to talk about is focusing on the carbon cycle. There is concentrated fossil fuel use. Okay, so you might not be driving individuals might not be driving quite as far as they would in a rural area, but there are so many more people and therefore there tends to be so many more vehicles. Los Angeles is a great example of that and is well known for its horrible traffic. Okay. You also have very high electricity demands, which ramp up the fossil fuel use, whether that is coal burning power plants or natural gas burning power plants. You have lots of manufacturing and industry that can occur in city. And again, manufacturing and industry, some of those factories, not all, have their own emissions that they create. And some of those can be fossil fuel related. For example, a steel smelting plant is going to use either coal or natural gas to heat up that steel to melt it. So they're going to have their own emissions just like a power plant. Okay. There's going to be large amounts of concrete. I have a slide specifically for concrete, but concrete releases carbon dioxide when it's emitted. There's concentrated waste. So you have all of these people living in a very small area, very high population density. You have a very large amount of human waste that you need to get rid of. You have a very large amount of trash that you need to get rid of. And the decomposition of those, whether it is aerobic or anaerobic, is going to release carbon dioxide and or methane. Okay, and we'll talk about sewage treatment and landfills in another day, but anything organic will eventually decay if it's not burned or anything like that. And then shipping materials to cities. So it's hard to grow all of the food that you need for all the people in the city. So just for food alone, it's estimated that the average US meal travels about 1,500 miles from farm to plate. That is a huge amount of fossil fuel use. Now in the US, we've grown very accustomed to eating everything out of season and shipping it in from as far away as South Africa or Asia just to reach our dinner table, our dinner plates. But if we can grow that food closer to home, it would drastically reduce the fossil fuel use of transporting it. All right, so let's look at the hydrologic cycle. A couple issues related with supplying water for the people in cities. First off, demand can just outstrip supply. Okay, it can just be a greater rate than the supply is. This is especially This is worrying for surface water, definitely. The American West and the Colorado River are a great example of that. But in many cases, the surface water isn't wholly depleted because once that surface water gets extracted, it's used and much of it goes back down the drain to a water treatment facility or even down a storm drain where it returns back to the river. Denver is a great example of that. The South Platte going through Denver would be just like the barest little trickle as it went out of Denver if it wasn't for the wastewater treatment facility that was there that cleans all the water from our drains and puts it back into the South Platte. Okay, so that recharges the South Platte, that fills the river before it goes into the agricultural centers in Northeast Colorado. Now that doesn't mean that all that water goes back into the river, but at least a lot of it does. This is definitely especially worrying for groundwater though, because groundwater recharges on a geologic timescale or more or less on a geologic timescale, whereas we're extracting it in the course of decades, centuries. Okay, and increasingly, big cities and arid regions around the world are running into water supply issues, and much of that is due to overextraction of groundwater and the depletion of their aquifers. There's an added problem with this in coastal cities, and that's called saltwater intrusion. So I do want to stress that this is only for coastal cities because you have to have the ocean right next to it. Okay, so let's say that you have, using this diagram on the right, you have your water table, and this is fresh water in this light blue color. And you're pumping water out, you're pumping water out, you're pumping water out, you're watering your lawns, you're drinking that water, you're using it for manufacturing, bathing, everything that you do in a city or in a suburban area. Okay, so you're extracting that water from the aquifer. And that water, that's fresh water, is being used up and used up and used up. And what's going to take its place underground? Well, what's going to take its place is the salt groundwater or the saline groundwater that is going to essentially follow that fresh water as it moves further and further and further away, or as it becomes more and more depleted. Not moves further away, that's silly, but becomes more depleted. And as you extract it, you'll reach this point where the salt water is going to be the water that you're extracting, and you can't use that. Without treatment to remove the salt, you can't use it for drinking, for really washing your dishes because it corrodes metals so quickly. You can't use it for irrigation. It corrodes pipes, right? Your copper and iron pipes that not so much PVC, not PVC at all, but copper and iron plumbing, it will definitely corrode. Okay, so it has to be desalinized before use. And once you reach this stage, you might be able to tap a more shallow well, but doubtful. Once you reach this stage, it's kind of game over. Okay, so this is happening worldwide, everywhere, like I said, coastal cities, primarily in the drier regions. So you notice that several of these are dry areas around the Mediterranean, and then we have some US examples as well. Florida and Georgia, maybe not super dry, but happening as well. Sticking with the hydrologic cycle, let's look at runoff. Runoff is huge in cities because we have impermeable surfaces, surfaces that do not allow water to go through. Asphalt, concrete, glass, shingles, all of those things do not allow water to seep into the soil. Okay. Water is then directed into storm drains. Those storm drains really channel that water and funnel it en masse into the nearest waterway. Okay, that could be an oceanic waterway. Okay, so it could flow directly into the bay, but it could be a fresh water going directly into your nearest river or stream. Okay, it's really important to know that no storm drains filter water. They don't treat water. They have coarse grates on them that might remove some solid material, but they don't filter it, they don't strain it, they don't treat it. It goes straight into your local waterway, carrying all the pollutants that are there except for the largest of the solid waste. Okay. The other thing that this does is that it increases flooding. So all of these impermeable surfaces don't allow water to seep into the soil and to slowly go into the soil. And they don't allow groundwater to be recharged either because of that. And then they also increase flooding. Why? Because they're all funneling this massive amount of water straight into the creeks and streams, and those creeks and streams can and rivers can breach their banks and flood, or alternatively, they get to the level of the storm drain itself, and then the street starts to flood. So to look at the impacts of impermeable surfaces on flooding, let's look at Hurricane Harvey, which hit Texas in 2017. So my sister, kind of funny story, my sister moved down to Houston, South Houston, literally like 2 months before Hurricane Harvey hit. It was her first hurricane, and her entire family's first hurricane, right? Her husband, the kids, all that. So it was kind of bad timing on their part. Their house thankfully wasn't flooded too bad, but did sustain some flood damage. So Houston, little background, is the fourth largest city in the U.S. There's 2.3 million people living there, and it's got a huge land area, huge footprint. Okay, a lot of it due to the expanding suburbs around Houston. Hurricane Harvey was a Category 4 hurricane. It basically made landfall and then parked on top of Houston and just dumped torrential rainfall onto the city. It broke all of the um, the rain total records for Houston. Houston is built on a very flat coastal floodplain. Now, people really like to build on floodplains because it's where the great soil is, it's where you have a constant supply of water for agriculture, and that's where a lot of cities were created. I'm not sure specifically if that's the reason why Houston is where it is, but that's what I'm guessing. And because it's on a flat coastal flood plain, it's had lots of flooding throughout its history. Okay. Um, Houston doesn't have a major river that goes through it, but it is drained. Southeast Texas is drained by a series of bayous and small rivers and streams. Okay. There's been massive development, and especially urban sprawl, which we'll get to in a little bit, in Houston over the past, I don't know, 5, 7 decades. And that's greatly increased the amount of impermeable surfaces. So rather than all of the organic rich soil that's in a floodplain absorbing all of this water and slowly percolating all this water deeper into the soil, and yes, it will flood, but eventually, but it'll absorb a lot of water before it does. You now have these surfaces that don't absorb any water, but they channel all of that water into all of the various creeks and bayous and small streams around and in Houston itself. So just some facts about the urban sprawl. Um, in a 20-year time frame, about 25,000 acres of wetlands were lost to development. And as you guys know from the biomes projects, wetlands are great for absorbing and filtering water. Okay. Katy Prairie, which sounds very much like Katy Perry, but Katy Prairie has been reduced to about a quarter of its former size. Now it's only about 24,000 acres, which is the same amount of land that was lost just from wetlands to development. So this prairie has lost much of its land, and that again is organic rich soil that can absorb and hold onto water. Okay. So flooding would have happened anyway. There's no doubt that flooding would have happened. All the rainfall totals were just like, completely broken, but it wouldn't have been as bad. We'll get to how bad it was beforehand. But just one quick story about this development. When my sister, her husband, the kids, moved down to South Houston, they were kind of on that leading edge of the development. They were in a place called Pearland, and they bought, they rented rather, a pretty new suburban home before they can really get settled in. Just about a mile, I helped them move, so I was down there with them. Just about a mile south of us is where they were clearing out the prairies, the swamps, in order to, or the bayous rather, in order to develop more. So they would cut everything down. They would burn all the vegetation. You can smell it on the air, and then they would fill in the soil a little bit to raise it up slightly, and then build on that. So it was kind of stark contrast between the natural areas that I drove past because I went down and explored a little bit, and then the areas where they were burning this vegetation, and then the development that was like brand new, less than a year old, all within a couple miles of roadway. So just the expansion of the city, the urban sprawl, and all of these streets that are under this water in this picture that are impermeable to water. But let's get back to Hurricane Harvey. Caused about $125 billion worth of damage. You guys can read these facts and figures, but what I want to highlight is that there is at least 68 deaths directly from the storm, and then there were some after that as well. And this one is big because this one spreads disease. 40 wastewater treatment facilities became inoperable, and 150 gallons of sewage overflowed into the city. That is raw sewage that goes into these waterways and spreads disease. So that you have to have boil water notices. You have to boil your water to kill any bacteria that are in it before you can consume it. Okay. The pictures from Harvey are just insane. All of this, again, is due to the impermeable surfaces, or at least the exacerbated by, I shouldn't say due to, it's due to the hurricane, but it's exacerbated by the impermeable surfaces that do not allow water to drain. And you have streets that flood because the storm drains have essentially backed up because they've risen to the level of the rising creeks. Okay. Okay, so let's look at urban sprawl since I've mentioned it several times. Many cities where there is space are building out and not up, and that's especially of concern in the suburbs. Okay, now I know that you guys live in the suburbs. I live in the suburbs also, but the suburbs are not good. The suburbs are an environmental catastrophe, to put it bluntly. We'll talk about this in class a little bit more, but you have all of these homes that are not close to anything that you need, shops, school, whatever. And if it's close to one, like if you're close to school, you're probably not close to a restaurant or a grocery store, or your lumber yard, or whatever you need to get to. And that just creates all of this need for driving everywhere. You have to drive everywhere in the suburbs. Okay. But anyway, I digress. So you guys can see some of the pictures of the urban sprawl. Obviously, we degrade habitat as we do this. It increases the amount of impermeable surfaces, and there's many negative effects associated with just the habitat loss and the increase in impermeable surfaces, and the use for automobiles as transportation, for carbon dioxide and other pollutants in the atmosphere. So everything that we really talked about being a benefit of cities when they're small, confined, and everything's within walking distance is canceled out when you go to the suburbs. Now I'm going to show this video in class, but if you're going to be absent, check it out. So in this video, what you'll see is the expansion of the urban sprawl in Denver. What we're really looking at in this video is right here. But what I want to point out with this map is, and I know that it's a little bit too big, is a couple things. One is that we're basically, due to urban sprawl, Denver has absorbed all of the cities around it, right? It's now the Denver metro area. It's absorbed Aurora and, almost Boulder even. And as you move out past Denver, past Castle Rock, it's basically, as you drive up and down I-25, basically one large suburb from Denver all the way up to Fort Collins or Denver all the way down to Colorado Springs, broken by the occasional little patch of forest or the occasional bit of farmland. But the urban sprawl is insane around Denver. If we look out to all the geometric fields to the east, what you notice is that all of this is all this short grass prairie is converted to pasture and cropland, primarily wheat and cattle. So just wanted to quickly point that out, even though we're talking about cities here. A couple other disadvantages that are somewhat related to each other. The first is heat island effect. This is due to all the low albedo surfaces in cities absorbing solar radiation throughout the day and then radiating it back out over the course of both the day and night. Think about all the darker surfaces in the city, right? Shingles, asphalt, all of that stuff. Plus you have other surfaces that aren't quite as dark, like concrete, that still have a relatively low albedo and still absorb some thermal radiation. All of the metals that are exposed to the sunlight in the cities, etc. Okay, all of these low albedo surfaces absorb, like I said, thermal energy, and then they radiate it out over time, leading to what we call heat islands. And this process is called the heat island effect. So the process is the heat island effect that leads to heat islands, basically saying that the downtown Metline area or the city area is going to consistently have higher temperatures than surrounding even suburban area, which will then have constantly higher temperatures than rural or natural areas. Okay, so cities will constantly be hotter than the surrounding natural areas. You can see this in Denver also. When I lived in Denver or when I would commute to college in downtown Denver, it was on those days when it's like borderline rain and snow, it would often snow up in Aurora, but it would rain in Denver because the air around Denver is consistently hotter than it is in Aurora. And even when it's like just at that freezing mark or just below freezing, even 1 or 2 degrees Fahrenheit is enough to sway it from to be rain rather than snow in the city. You'll also note that snow tends to melt on roads and all of that stuff in the city quicker than it does in the suburbs or in the rural areas. Now, obviously, that only applies to areas where it's in full sun, but it still applies. Waste heat is somewhat similar, but waste heat is heat that is produced by machinery. So think about your car engine that gets pretty darn hot. You do not touch it after you've driven anywhere. Amplify that up to the millions of cars in a single city, and then add all of the millions of air conditioners and all of the other machinery that is constantly generating thermal energy in a city. Okay, if we're talking about winter, it might be because people have stoves and heaters that are, heat is escaping through the chimney, what have you. Okay, so this contributes to heat islands, or it can contribute to heat islands, but the heat island effect and waste heat are definitely not synonyms, and they're not the same. But the heat island effect causes heat islands, and waste heat can contribute to heat islands. All right, let's look at concrete. Concrete and other building materials such as mortar are used heavily in cities, right? There's just a lot of concrete structures in cities. Not to say that there's not concrete that's being used in rural areas, there absolutely is, but in cities there's heavier use just because there's more people and buildings and roads and all that stuff, okay? Sidewalks, etc. Concrete is a mixture of cement and aggregates. So that cement is lime or calcium oxide, which is up here, and you typically have clays in there, which makes cement. And the most common one is Portland cement. And obviously, like, there's a whole production process, and I'm just barely scratching the surface on what it actually is, but that's basically what it is. And then you have aggregates in there as well. So if you've ever mixed concrete, you know that there's sand, you know there's probably some pebbles, or that there is pebbles in there, etc. And then you combine it with water, makes it workable so that you can mold it or form it or spread it, and then it hardens. Okay. When it hardens, the water does not evaporate from concrete. The water is kind of locked in that, and you would never know that it is. But if it evaporated, then it wouldn't really work. It would absorb water every time that it rained like a sponge, but that water is kind of trapped in it. It doesn't evaporate off. Okay. So let me get back to the point here. The point of this is that when you make cement, or more specifically, when you make lime, you release carbon dioxide. Okay, so what you do is you take limestone, calcium carbonate, and you heat it up in these giant ovens that they use, and that produces your calcium oxide, also known as lime, which is CaO. What happens to the C and 2 of those oxygens? Well, they form carbon dioxide, and that is released as a gas, as a waste product. Okay, because this is a chemical formula, and because you need lime for mortar and cement, there's really no way around this besides using less concrete or using other materials to supplement some of the material in the concrete, right? You still are using lime, but you're using other materials that are often waste materials from other processes, like fly ash from coal burning power plants, blast furnace slag from metal foundries, or other materials instead of the cement, or creating new materials rather than cement. So if you want to read this article, or just check out this article. I don't think that we'll have time to go over it in class, but it's looking at some eco-friendly alternatives for concrete. Okay, because this is a chemical process, it's not as simple as just change one of these things. There's actually a lot that goes into figuring out different products that can make as good of a building material as the stuff that we're used to, that are also sustainable and eco-friendly, right? And then finally, let's just wrap up the negative impacts of cities with some health effects on people. First off is air pollution, right? Air pollution can lead to all kinds of respiratory or cardiovascular diseases. There's the diet of people in cities, right? People in cities tend to be living fast, and they tend to need a quick meal, and that gives rise to fast food. People in cities often live a more sedentary lifestyle than the people that live in rural areas, which leads to negative health effects like obesity, hypertension, etc. Okay, and then you have the increase in disease transmission due to high population density. Recall that this is one of our density dependent limiting factors. And if we have a, let's say, respiratory virus that that pops up, it's really easy to spread it in densely packed cities, right? One person on a crowded subway car gets it, then everyone on that crowded subway car has the potential to get it, right? Is exposed at least. So let's quickly look at one of the other learning objective. We spent a lot of time on urbanization, but let's look at some ways to mitigate urban runoff. So again, runoff is exacerbated in urban areas due to all of the impermeable surfaces that you use. So why not just switch to a permeable surface? People have come up with something called permeable pavement, and permeable pavement is exactly what it sounds. It's pavement that doesn't that does allow water to pass right through. It can go to the soil right beneath that pavement. Okay, and then it can be added to groundwater, whether that's surface or even percolate deeper into the ground. Okay, this is more expensive to make. It's more maybe not quite as durable as traditional concrete, but it definitely reduces the amount of urban runoff. Okay, and it's getting better all the time and cheaper all the time. The natural method is to use soil and plants in your favor, right? Wherever you have an area that is not planted with trees along the side of a road, right? Remove some of the concrete, remove some of the impermeable surfaces, plant grasses, shrubs, trees there. Those are what we call greenways, okay? We can plant green roofs. Now you do have to have sturdy enough roof to do this. So you have to think ahead when you're building a building or retrofit a building at least, because there is the soil weight and then the water weight on top of that. So green roofs are a great option. All of the water that falls onto this roof, some of it is hitting these impermeable surfaces, but much of it is hitting this green stuff, which has soil in it and is being absorbed by the soil. Community gardens are great. Not only does this reduce urban runoff, you create a large area with plants and soil, but you also reduce some of the food shipping that is required for these cities. Now, because of the population densities of cities, it's very difficult to feed everybody in the city using community small-scale gardens, but it supplements it. It's at least better than nothing, right? Okay. And then any type of open area with vegetation and soil will help mitigate runoff. We'll watch a video about this in class that explains it and shows some facts and figures with it and why. Building up, not out, so you reduce that urban sprawl and you get rid of the suburbs. That will reduce the amount of impermeable surfaces. Okay. All of these are going to help increase infiltration. That increased infiltration can help recharge aquifers, even though they do recharge very slowly, we can help recharge them. And it uses soil to filter that water. So we didn't really talk about it much, but all of the pollutants, say that you have like a greenway, okay? So say that you have your road, which I'm gonna do in red, and then you have a greenway. So water that hits this road goes into the soil, and then it goes into a storm drain. That will help filter that water. That soil will help filter that water before it goes through that storm drain, okay? Rather than just going straight into a storm drain, carrying all of the pollutants on that road straight into that storm drain, okay? We'll talk about that in class also. I'll use the example of the retention pond on the Grandview campus, but you might want to write down retention, sorry if I can spell, that was ridiculous, retention or detention ponds. Okay, write that down. We'll talk about those in class. A couple of the other negative effects of cities that we've talked about, and we'll talk about more as we go through this school year because this is just a very short bullet point list and definitely not all inclusive. But growing local food reduces transportation emissions, right? I would add eating seasonally, right? Don't expect to get grapes in January if you live in Denver. Those grapes have to come from somewhere, and they're probably coming from many thousands of miles away because they're being grown in Chile or Argentina or South Africa, right? That's a very long distance for food to travel. Eat seasonally, right? And winter, eat winter squash, not grapes, or raisins at least, right? Because they're dried. But that's my own little pet peeve, and I'll get off my soapbox. Renewable energy sources can reduce the amount of greenhouse gas emissions or pollution. So I think that, you know, material cost aside, every flat roof in the city should have solar panels, right? If you, many of you guys have probably ridden the light rails in Denver, and when you're getting to the Broadway station from the Aurora area, going on the H line or the F line or something, you'll go up on this bridge and you'll be able to see down on all these flat roofs in the industrial or commercial part of Denver, and not one of them has solar panels. Why should they not, right? It's a lot of wasted space. This also includes vehicles, right? Renewable energy sources. We can throw even though it's not renewable, we can throw electric vehicles in there too, Okay, electric vehicles are not renewable in the sense that they need all the materials for the batteries that have to be mined and all of that. They have the electricity cost could be coming from fossil fuels. So if you don't have solar panels on your house and you're not getting your energy from hydroelectric or wind, and you're using electricity that's from a coal or natural gas burning power point to charge your EV, then it's not renewable. But it still reduces the emissions from vehicle pollution. Okay, so we could throw that, maybe I shouldn't throw it in up there, but maybe we should talk about it down here with public transit, talk about electric vehicles down there to reduce greenhouse gas emissions. Urban planning is big. Again, we'll talk about that in class, so I'm going to skip that little part of this. I have two videos that I was going to show you guys in class, so if you're not going to be in class, check these out at home. One is where does stormwater go? Pretty good animation of where stormwater goes, right? And the second one is the one that I'm going to use to talk about urban planning. This one is pretty good, if a little bit biased. Okay, so let's get back to the learning objectives, the essential knowledge actually. So urbanization can lead to depletion of resources and saltwater intrusion in the hydrologic cycle. Again, saltwater intrusion because you're extracting all the fresh water from the water table and that salt water from the ocean is following it. Really important that you know that that's only for coastal cities. Urbanization through the burning of fossil fuels and landfills affects the carbon cycle. We'll talk about landfills on their own day. Which releases carbon dioxide. I would add methane to that. Oops, CH4, geez. Not the burning of fossil fuels for methane, but landfills for methane. Okay, burning of fossil fuels will obviously just be CO2 and carbon monoxide and all of the other pollutants, but we'll get to those on their own day. We have the impervious or impermeable surfaces. You can use those two terms interchangeably that don't allow water to reach the soil and increase flooding. Okay, so water does not percolate into soils. And then urban sprawl, huge problems from urban sprawl. Okay. Methods to reduce urban runoff. They include replacing traditional pavement with permeable pavement, planting trees, increase use of public transportation, building up, not out. With this planting trees part, I would say any type of vegetation, whether that is grasses, shrubs, vegetables, what have you, but trees are absolutely great. All right, let me know if you guys have any questions. I'll see you on class. Bye.